Okay, good morning. Yeah, this lesson that I want to start here now is actually a very short lesson. So very short lesson actually. Let us just do it. And then if you want, I can give you time to practice a little bit. So that is called the Cartesian product of two sets. So if you remember, if we had two sets, A and B, we could union them, intersect them, subtract them. And if I have one set, I can take the complement of that set. There's also another operation between two sets, which is of different nature, and that is the Cartesian product of sets. Before starting about it, we need to know the notion of an ordered pair. So what do we mean that I have an ordered pair? So assume that I have two objects. I call one of them A, I call the other one B. When I put them in order, it means that I have an ordered pair. That's it. Okay, so, and usually we don't write it like this. We put this brackets A, comma B, brackets closed. Whenever you see this, you are facing an ordered pair. It is different from the set consisting of A and B. Yes, these two things are different. So if you remember, this set is not ordered. So if you have the set consisting of two objects A and B, it is exactly the same thing if you write it as B and A. But sometimes in mathematics, we need the notion of order to be considered. For example, can you give me a good example in which we actually need this rather than this? So I mean, can you give me an example where we need having an order between the numbers that appear? And that is just the normal coordinate system, yes? Where, for example, if I say that I have a point 1 and 2, and if I say that I have a point 2 and 1, even though 1 and 2 and 2 and 1 are the same numbers, but hopefully you know that this point and that point are different points, yes? For example, if I want to locate the first point, let me call it A, and let me call this B. X coordinate is 1, and the Y coordinate is 2. So that is this point. And then the X coordinate is 2, and the Y coordinate is 1, that is this point. So you see that when I change the order of appearance of these two numbers, something is changing, yes? The point A is now point B. So I mean, and these 2 points are not the same. So in mathematics, sometimes we really need to consider about the order. In those cases, we talk about an ordered pair. So in general, the ordered pair A and B is not equal to ordered pair of B and A. Another difference is probably if I repeat an element in a set, that would be the same set as if I just write it one time, yes? But here, I can write A and A, and there is no way for me to simplify it because I need both of them. For example, I can say I have a point with coordinates 5 and 5. I cannot just say drop one of the 5s, yes, because we need both coordinates. So this is the difference between an ordered pair and a set consisting of two elements. Okay. So the first thing we need to know, by the way, when I talk about an ordered pair, A and B, this is called the first component. The first component, and this is called, of course, the second component, yes? Okay, and now if I ask you when these two ordered pairs are equal, I give you two ordered pairs, A and B, and I give you another one, C and D. I want to define when we say that these ordered pairs are equal. Okay, what is your idea when these two ordered pairs are equal? Yes?
When A is equal to C
and B is equal to. This is a good way of defining this. So we say that this happens if and only if the first components match and the second components also match. Yeah, you don't need to prepare brackets. Okay. So this means and, yes? Okay. Now let us consider two sets, A and B. I want to define the Cartesian product between these sets, A times B, which is exactly denoted by the usual multiplication symbol. But be careful, this is not normal multiplication, because normal multiplication goes between numbers, but these are two sets, we want to Cartesian product them. So this is the definition. When you say what is the meaning of the Cartesian product of A by B, this means the set, so A and B are given sets, and I want to define A cross B. This is the set consisting of all ordered pairs, okay, such that the first component comes from the first set and the second component comes from the second set. Yes? This is the definition of the Cartesian product of two sets. Just a very simple example. If I give you A to be the set of 1 and 2, and if I give you another set B, 2 and 3 and 4, we can write these, we can find these sets. For example, I can ask you what is A cross B. I can ask you what is B cross A. I can ask you, for example, what is A cross A. Yes, I can also ask what is B cross B, of course. But let us try to write them down. So A cross B, A is the set 1 and 2, and then cross B is 2, 3, and 4. Yes, and then we want to write all possible ordered pairs where the first component of that ordered pair is on the left side set, and the second component is coming from here, but you have to write all possible combinations. Okay, so just very simple fact. Yes, you just open a curly brackets, then you say that I can choose 1 from the left set, 2 from the right set, so it becomes 1 and 2. Or, so because now this is one element of this set. As a whole, this is one element. And then I can say that, okay, now I can choose one again from the first set, but 3 from the second set. I can choose 1 still from the first set, and finally 4 from the last set. So far, I have written 3 elements of this set, but the elements of this set are ordered pairs, not just normal numbers, okay? And then hopefully you know what to do, yes? There is no other ordered pair that I can write with the first component to be 1, so I switch to 2, and I repeat the process. So this becomes 2 and 2, 2 and 3, and 2 and 4. That's it. So that is the set. If I ask you what is the cardinality of A cross B, what is the answer? Yes? It is 6, because you don't consider these as different elements. This one as a whole is one single element. So how many of them are there? 6 elements, yes. And let me just do B cross A. B cross A means 2, 3, 4 coming first, then multiplied by 1 and 2, Cartesian product. Okay, and then this time I need to also write the elements, the ordered pairs, but this time the first component is coming from the set on the left hand side. So I have, for example, I can start with 2 and then 1, and then I 2 and 2, and then I have 3 and 1, and then I have 3 and 2, and then I have 4 and 1, and then I have 4 and 2. Yes? Again, if I ask you what the cardinality is of B cross A, again, you count them and see that this is 6. And in combinatorics, that is a very important topic that we will study later. This is called the product rule. Yeah, we'll talk about that later. Okay, and then what I can do, I can talk about A cross A. So what does it mean? It means that I can take the set A and Cartesian product it with itself. Yes? And then what I do the same thing. So I take 1 and 1. I take 1 and 2. And then I can take 2 and 1. And then I take 2 and 2. And by the way, usually people denote it by A. We can say A to power 2, but power is just for numbers, but this is the symbol notation we use for this one. So whenever you have a set, for example, if I give you this set and I ask you square it, what do I mean? I mean to cross product it by itself. Not cross product, Cartesian product it by itself. What is the answer? There is only one single element there, and that is 1 and 1. Okay, so this is, I don't use it, but I hope that you know that. When you see have a set squared, it means Cartesian product the set with itself. Okay, and then here, do you think that A cross B is equal to B cross A? So A cross B is this set that you see here, consisting of 6 elements. B cross A is also here, consisting of 6 elements. But do you think that these two sets are equal? No, because of the definition of the ordered pair, yes? So for example, the ordered pair that you see here, 1 and 2, does not appear here. The closest to 1 is 2 and 1, but 2 and 1, based on the definition of the ordered pair, is not equal to 1 and 2. So in general, it's not commutative, yes? The Cartesian product in general is not equal to A, in general. Yes? So it is not commutative. But for example, let me ask you one question. Can you answer this question? I can cross product A, I can Cartesian product A and B, and then B and A. And then, for example, let us look at the intersection between them. Because we can also talk about intersection of any sets. This is a set at the end. This is also a set. Now this intersection makes sense because I am putting it between two sets. But sets of different natures, it doesn't matter. This is a set, I can talk about the intersection. Is there any intersection between A cross A, B, A Cartesian B, B Cartesian A? Is there? Yes? 2 and 2. So you just write, that is the only one, 2 and 2. If I ask you what is the cardinality of this set, what is the answer? I just want to, these are very simple facts. I just want to, what is the cardinality of this? 1, because it consists of one element, and that is 1. Okay, so let us try to ask you one question. So what do you think will happen if I Cartesian product any set with the empty set? Because it should make sense, yes? Because I told you that I give you any two arbitrary sets, then I ask you to Cartesian product them. You will tell me what I need to put there are all the ordered pairs where the first component is coming from the first set, the second component is coming from the second set. But what do you think I should be able to put here? Yes?
Yes.
The empty set, yes? So this is interesting. So it is comparable to when you say a number multiplied by 0 is 0, but that's different, completely different story. But in this case, what do you think? Do you think even though it is not commutative, what can I write for this one? Yes? Again, the empty set. Is that understandable why it is the empty set? Because if you say it is not empty, it means that you should be able to find an ordered pair where the first element is coming from here, the second element is coming from here. But this is not possible at all because this doesn't have any elements in it. That's the reason why this is empty. So this is an exception. This is what I have written in general. So here, but you see that A Cartesian product with empty set and the empty set Cartesian product with the set, they are both equal to the empty set. So that was an exception. Okay, and then can you say something about, because that would be the main importance for us later. So if I give you two finite sets, A and B, and I ask you to write a formula for the cardinality. I have two finite sets A and B. I cross product them. Hopefully you agree with me. It also becomes a finite set. Do you think there is a relation between the cardinalities of A and the B and the cardinality with A cross B in general? Yeah, it is. It should be simple to guess. Yes. Yes.
Is it cardinality of A
times cardinality of B. So this is the way your book has started the multiplication principle, and or rule. We'll talk about that later. So if A and B are finite sets, then we can have this rule. Okay, one more exercise we can do and then finish that. So for example, I give you a set 1 and 2. I give you another set B 3 and 4. Okay, I want you to check this equality. Do you think this is true or false? Let me make it 2 and 3 so that we have also some intersection here. So what do you think will happen here? Is this correct? This is a very interesting way of understanding this. First of all, I want you to understand my notation. So this is optional. First of all, can you interpret this relation? It's very similar to something like this. A times B squared is A squared times B squared, yes, in numbers. A squared, this is just for numbers. First of all, do you agree such a thing that you see makes sense? What does this power of 2 mean here? This means that I have two sets, I intersect them, and square it according to what I described here. So it becomes a set of ordered pairs. And then you do the same thing for A, it becomes a set of ordered pairs. You do the same thing for B, it becomes a set of ordered pairs, and then you intersect them. This claims that these two are equal. Okay, let us check that and then the lesson is finished. So if I want to calculate the left-hand side, what do? Instead of A, I put 1 and 2. Intersection, instead of B, I put 2 and 3. And then I square it. But I want you to understand what is the meaning of a square. It means Cartesian product of the set with itself. But before doing that, the priority is of course given with the operation in the pair of brackets. So I intersect them, which is what? Only 2. And then I square it. But what is the meaning of a squaring of a set? Means Cartesian product the set with itself. And then hopefully you agree with me, this is just 2n. Yes? So this is the left-hand side. It is a singleton. It consists only of one element, and that element is the ordered pair 2 and 2. Okay, now the right-hand side is a squared, which means 1 and 2 squared, intersection 2 and 3 squared. So I have to intersect these two. So before intersection, I need to know the answer to this. I need to know the answer to this in order to be able to intersect them. So the answer to this means what? Means Cartesian product is set with itself. The meaning of this is exactly the same. Cartesian product is set with itself. Yes, and then whatever happens, I want to intersect that. Okay, so let me write this here. Okay, so what happens? The first one is just I Cartesian product these two sets. Hopefully you agree with me. This is just 1, 1, 1, 2, and then 2, 1, finally 2 and 2. And then I take it the intersection with the Cartesian product of this set with itself, which is 2 and 2, 2 and 3, 3 and 2, and what? 3 and 3. And now I ask you, find the intersection, the overlap between this set and that set. Hopefully you see that there is only one element there which is in common, and that is 2 and 2. Yes? So the left-hand side is equal to this. The right-hand side after that calculation is also this. So they are equal. So this is number 2 and this is number 1. So comparing number 1 and 2, I can conclude that these two are, the left-hand side is equal to the right-hand side. Yes? Okay, any questions? Okay, so your book has started combinatorics and talks a little bit about Cartesian product. But I think this is more or less related to the set theory yet. And then we can use so from next time we will actually starting a very exciting branch of discrete mathematics, which is called combinatorics. Okay, so that's very exciting and sometimes extremely hard. So they are very easy to state, but sometimes extremely hard to solve. Okay, any questions? Okay, so we end the lesson here now. Thank you.